Hello everyone, welcome to this new session. In the last sessions, we have discussed the first order and second order control systems, right? And a few of the case studies also we have discussed for different values of zeta. That zeta is called as the damping ratio, okay? That I forgot to tell you, okay? The value of zeta, the zeta is called as the damping ratio or the damping factor, okay? Yeah. So now, in the next few sessions, we are going to see through few of the derivations, and we are going to solve some problems related to these time response, unit step response specifications. Okay, yeah. So after that, we would be completing this module. So now let's start with one very important and complicated derivation, that is the derivation of unit step response of a second order underdamped system. Okay. So now what this would be resulting to. Okay, so now first let's start with this derivation. I've already made this derivation for you. Okay, this note is available, so I'm just going to explain it to you all. This is a very big derivation, but yet it's very easy if you understand the steps very carefully. Okay, so now first let's consider for underdamped system. We know that whenever the response of the system is underdamped, the value of zeta, that is the damping factor, is less than 1. Okay, is less than 1. Okay, so we know that for a second order system, during its analysis, we have found this denominator term, and this denominator term can be represented as a characteristic equation, okay, that is equal to 0. This has two roots, okay. So the two roots here are, which we are obtaining, is this is zeta, okay. These are the two roots which are obtaining, that is minus zeta omega n plus or minus j omega n into square root of 1 minus zeta square. Okay, if we take its roots, okay, if we try to solve this, and we would be getting these two roots here. Okay, so now in this equation, put the value of zeta omega n, okay, is equal to alpha. Okay, similarly, the value of omega n into square root of 1 minus zeta square is equal to omega d. Yesterday we have seen that relation, right? What is that relation? Omega d is equal to omega n into square root of 1 minus zeta square, right? So this is the relation yesterday which we have seen, okay, where this omega d is the damping frequency and omega n is the natural frequency of oscillations. Okay, so now substitute this value of zeta omega n and omega n into square root of 1 minus zeta square in this equation, that is s of 1 comma 2, that represents that there are two roots in this equation, that is equal to minus of alpha, since zeta omega n is equal to alpha, plus or minus j into omega d. Okay, so now since we are doing the derivation for a unit step response, so for unit step response, take the value of r of s is equal to 1 by s. Okay, since the given signal is a step signal, so that's why r of s is equal to 1 by s. So our c of s by r of s is equal to this term for second order underdamped system. We know that this is the equation, right? Omega n square divided by s square plus 2 zeta omega ns plus omega n square. Okay, so therefore, since the value of r of s is equal to 1 by s, so they will be only remaining with the term c of s, that is equal to omega n square divided by 1 by s into the same term, that is s square plus 2 zeta omega ns plus omega n square. Okay, so now the next step what we need to do is, we need to be finding the partial fraction calculation, okay, in order to find the inverse Laplace transform of this c of s. Okay, so if we take the inverse Laplace transform of c of s, that would be converted to the time domain c of t. Our goal is to find the expression for c of t at the end. Okay, yeah, so that would be your output response. So step by step we need to be solving now. So now we need to be doing the partial fraction calculation in order to get the inverse Laplace transform. Okay, so now for this equation we need to be doing the partial fraction calculation, that is, write this term, that is equal to a1 by s, that a1 is a constant, okay, plus, since we have this term, that is the power degree of the first term is square, so a2 into s plus a3 divided by s square plus 2 zeta omega ns plus omega n square. Okay, then again cross multiply, and that is a1 into s square plus 2 zeta omega ns plus omega n square plus s into a2s plus a3 divided by the multiplication of the denominator, so that we could cancel the denominator. So now the remaining term is omega n square is equal to s square into a1 plus a2. Okay, since if we multiply this, what we would be getting, s square into a2 plus s into a3. So in this s square is common, take it outside, s square into a1 plus a2 plus s into whatever the terms are there in with s, that is a1 into 2 zeta omega n plus a3 plus the constant term, that is a1 omega n square. Okay, so now here we need to be doing few of the calculations. That is, first thing what we need to do is whatever the constants are which are present in this equation, equate them. Okay, so how would we equate the constants? So this is one constant here without any s variable, so this is one constant and this is one constant, so equate them. That is a1 omega n square is equal to omega n square, equating constants. Then equate write the coefficients of s square in this equation. Okay, that is coefficient of s square. Here we don't have any s square term, so that is equal to 0. So here in this case the coefficients of s square is a1 plus a2, so that is a1 plus a2 is equal to 0. Okay, so the next step is we need to be equating the coefficients of s. Okay, that is a1 2 zeta omega n, that is the equation of coefficient of s, that is a1 2 zeta omega n plus a3 is equal to 0. Okay, so now we can consider the equation 1 here, that is which we are after equating the constants here, a1 omega n square is equal to omega n square. Okay, if we bring one omega n square down here, so it would be a1 is equal to omega n square divided by omega n square, so that we can cancel them. So our value of a1 which we are getting, that is equal to 1. Okay, same goes with the second equation, that is after equating coefficients of s square, the equation we are getting is a1 plus a2 is equal to 0, right? So in this equation we can substitute the value of a1 as 1, so 1 plus a2 equal to 0, so our value of a2 we are getting it as minus 1. Okay, so similarly in this equation if we substitute the value of a1 as 1, so our answer which we are getting for a3 is equal to minus 2 zeta omega n. Okay, so now these a1 a2 and a3 we need to substitute back in the required equation, that is which we have taken before during the calculation of partial fraction. The value of a1 a2 and a3 substitute in this equation, that is c of s is equal to a1 by s, right? So the value of a1 is 1, so 1 by s plus minus s minus 2 alpha divided by s square plus 2 zeta omega n is equal to alpha, so that's why alpha s 2 alpha s plus omega n square. So here in this term take this minus term outside, so in the bracket we can write it as s plus 2 alpha divided by s square plus 2 alpha s plus omega n square. So name this as equation star here. Okay, so now continue, that is take the denominator side of this equation, that is s square plus 2 alpha s plus omega n square. So we need to be using one method for completing square method, that is last term divided by middle terms whole square divided by the 4 into first term. This is one formula or trick for finding some of the roots or an equation, roots of an equation, that is for completing square method. Okay, so now the last term is equal to middle term whole square divided by 4 into first term, that is we need to be considering the coefficients only. Okay, middle term whole square, so 2 alpha whole square, that is equal to 2 alpha the whole square is equal to 4 alpha square. Okay, that I have written, divided by 4 into first term's coefficient, that is 1. 4 into 1 is 4, so we can cancel this 4 and our remaining answer is alpha square. So now what we need to be doing this alpha square is, this equation we have taken it, right? So in this equation we need to be adding and subtracting alpha square, that is plus alpha square minus alpha square. Okay, so adjusting the denominator as s square plus 2 alpha s plus alpha square plus omega n square as it is minus alpha square. Okay, so now after that this term, if you observe here, this is of the form a square plus 2ab plus b square. Okay, so write it in the form of a plus b the whole square, that is s plus alpha the whole square plus omega n square minus alpha square. So name this as equation 1 here. After that we know that we have taken initially the value of alpha is equal to zeta into omega n. Okay, so therefore alpha square is equal to zeta square into omega n square, name it as equation 2. Then substitute back this value of alpha square in this equation, where here in this case we have taken alpha square, right? So in place of alpha square we need to be substituting zeta square omega n square, that is s plus alpha the whole square plus omega n square is minus zeta square omega n square. Okay, so again if we see that in these two terms the omega n square is common, take it outside and the remaining term write it inside, that is 1 minus zeta square. So s plus alpha the whole square plus omega n square into 1 minus zeta square. So put it in the box and write it as equation 3. Okay, So now we know that omega d is equal to omega n into square root of 1 minus zeta square. Initially we have taken this assumption, right? So now taking this assumption, now we can do few more calculation, that is take square on both sides, okay? So that is omega d square is equal to omega n square into square root of 1 minus zeta square the whole square, okay? That is equal to, if we simplify this, square root and square would be getting cancelled. So our remaining answer for omega d square is equal to omega n square into 1 minus zeta square, okay? So initially in equation 3 we had in this place omega n square into 1 minus zeta square, okay? But if we do this calculation, what you are getting, this is equal to omega d square, right? So replace that value of omega n square into 1 minus zeta square into omega d square. So this is the simplified expression of the denominator where we started from the completing square method, okay? So yeah, this is our required denominator now. So again put this denominator value back in the assumed partial fraction which you have taken, that is for c of s is equal to 1 by s minus s plus 2 alpha divided by, so replace the denominator by this term now, that is s plus alpha the whole square plus omega d square, okay? Then again split this 2 alpha as alpha plus alpha, so that is 1 by s minus of s plus alpha divided by s plus alpha the whole square plus omega d square. Then c of s is equal to 1 by s minus, so s plus alpha divided by s plus alpha the whole square plus omega d square plus alpha divided by s plus alpha the whole square plus omega d square. So I have just splitted the numerator and I have written the terms, okay? So now next step what we need to do is, in order to take the Laplace transform easily, so next step what is we need to do is c of s is equal to 1 by s minus of s plus alpha divided by s plus alpha whole square plus omega d square. This remains as it is. So in this term we need to be multiplying the numerator and denominator by omega d, okay? Omega d we need to be adding the terms numerator by denominator, so that is alpha divided by omega d into omega d divided by s plus alpha the whole square plus omega d square. So if we add this omega d term, it's one in the same, if it gets cancelled and only this term only we are getting. So that's why we are doing this, in order to take Laplace transform, okay, in order to bring it to that form, okay? So now we need to be taking Laplace transform for this equation, that is Laplace transform of 1 by s is equal to 1 minus Laplace transform of this term, okay? So this term, if you observe carefully, it is of the form s plus a divided by s plus a the whole square plus b square, okay? The Laplace transform of this term is equal to e to the power minus at cos bt, okay? So yeah, that's all, that only I have written here. In place of alpha we have a, and in place of b we have omega d. So that's why our Laplace transform what we are getting, e to the power minus alpha t cos bt, that is omega dt, minus, so why this minus has come, because I have removed this bracket, so minus into plus would be minus alpha divided by omega d, keep it as it is. Again this is of the form b divided by s plus a the whole square plus b square. Its Laplace transform is e to the power minus at sin bt, okay? E to the power minus at sin bt. So in place of b we have omega d, in place of alpha, in place of a we have alpha. So that's why we are getting e to the power minus alpha t sin omega dt, okay? So again put this in a box and make this as an equation. But here again take the assumption values which you have taken, that is alpha is equal to zeta omega n, omega d is equal to omega n into square root of 1 minus zeta square. So substitute back these two terms in this equation again. So what we are getting, c of t, so this c of s is turned into c of t now since you have taken the Laplace transform. So c of t is equal to 1 minus e to the power minus zeta omega nt cos omega dt, okay? In place of alpha I have written it as zeta omega n cos omega dt. Here in place of cos omega d we should not be changing anything, okay? Minus, in place of alpha again zeta omega n divided by omega d into e to the power minus, so here again we need to be writing it as zeta omega n e to the power minus zeta omega nt, okay, into sin omega dt, okay? So now here we can take this 1 minus e to the power minus zeta omega nt common, okay? This is plus 1, and in the bracket the remaining terms, that is cos omega dt plus Okay, since here we have minus, so if we take the bracket, it will be plus into plus zeta omega n divided by, now in place of omega d we need to be writing omega n into square root of 1 minus zeta square into sine omega dt, since we have taken this e to the power minus zeta omega nt common outside. Okay, so now what we need to be doing is cos omega dt into omega and omega n would be getting cancelled. Okay, so the remaining term is zeta divided by square root of 1 minus zeta square sine omega dt. So c of t is equal to, take this 1 minus zeta square outside, so our answer is 1 minus e to the power minus zeta omega nt divided by square root of 1 minus zeta square. If we take this square root of 1 minus zeta square outside, so inside the bracket what and all the terms are left, since here we have cos omega dt and divided by square root of 1 minus zeta square if we have taken outside. So if we had this term in the in the denominator, square root of 1 minus zeta square, in the numerator also we should be having it in order to get only cos omega dt, right? So that's why multiply square root of 1 minus zeta square in the with the cos omega dt plus 1 minus zeta square you have taken outside here, so the remaining term is zeta sine omega dt. Okay, so now we have one trigonometric formula here. If you observe the bracket very carefully, it is of the form of sine of a plus b. Okay, the formula is sine a cos b plus cos a sin b. Okay, it is of the form of that only. So how it is of the form, see, in place of a if we substitute the value as omega dt, okay, omega dt, plus in place of b if we substitute the value of theta, so sine of omega dt plus b theta, what you are getting, sine omega dt cos theta plus cos omega dt sin theta, that is sin a cos b plus cos a sin b. In place of a we have omega dt and in place of b we have theta. Okay, so now how we compare this equation with this equation in the bracket. So now if we observe very carefully, here we have cos omega dt, right, and cos omega dt, along with that we have the term square root of 1 minus zeta square. But here in this case, in place of cos omega dt we have sin theta, so we can equate sin theta and square root of 1 minus zeta square. Okay, comparing the above equation with the which we have obtained in the bracket, so we will be getting sin theta is equal to square root of 1 minus zeta square, and also zeta is equal to cos theta. How? See here, zeta sin omega dt, but with cosine omega dt we have theta, but here with sin omega dt we have cos theta, so cos theta is equal to zeta. So now what we can write, sin theta by cos theta is equal to square root of 1 minus zeta square divided by zeta, that is sin by cos is tan, so tan theta is equal to square root of 1 minus zeta square by zeta. So from this all expression we can get the value of theta here, that is angle of time response, that is theta is equal to tan inverse of square root of 1 minus zeta square divided by zeta. Okay, so this one formula we need to be remembering very carefully, because this formula is very important. The value of the formula for theta, okay, that is tan inverse of square root of 1 minus zeta square divided by zeta. Okay, so this is expressed in radians, okay, not degree. Okay, whenever you are doing the calculation we need to set the calculator in radian mode and then calculate the value of theta. Okay, you should not be forgetting this. So now finally our c of t expression, what we are getting is 1 minus e to the power minus zeta omega nt divided by square root of 1 minus zeta square remains as it is in the outside part. So whatever is there in this bracket is replaced by sin omega dt plus theta. Okay, so that's why I have written it here as sin omega dt plus theta. So this is our final expression for unit step response of a second order underdamped system. Okay, this is the output response which we are getting after all of these derivations. Okay, so this expression we need to be getting at final, so hence proved. So here I have one plot here where I have drawn one CFT plot with the time. Okay, so here I have drawn one random signal and it's rising up, and it after a few time it is becoming constant. So after that we can say that this region here This region here is called as the TD, or we can say it as a delay time. This region here, okay, it's called as a rise time, where the curve is getting rising and it is moving up, it is moving above the level of amplitude, that is 1. Okay, in generally we can take it as 1. Then after that, after crossing the amplitude and again coming down, and the range here, this range is called as MP, and this MP is called as peak overshoot. Okay, and again after some time, so this is called as rise time, so this is called as peak time, okay, TP, and this is called as TS, that is settling time. Okay, so let's see what and all are these terms, that is rise time, settling time, peak overshoot, delay time, peak time. Okay, let's see its definitions. Okay, there are a few definitions now that we are going to see now. So now, what is this delay time? Delay time, or TD, it is the time required to reach the 50% of the final value of the response in the first attempt. Okay, that is, the final value of the response is, for example, if it's set as 5, its 50% is called as 0.5. Okay, so that 0.5 is called as the delay time. Okay, the expression for delay time is given as, this formula is very important, you need to be remembering, that is TD is equal to 1 plus 0.7 times zeta divided by omega n, where zeta is the damping ratio and omega n is the natural frequency. So this is about delay time. Rise time definition is time required for response to rise from 10% to 90%. Okay, that is the sudden rise, the sudden change in time. Okay, so that range is called as rise time, and we are having one formula for that, that is TR is equal to pi minus theta divided by omega d, where the value of theta is equal to tan inverse of 1 minus square root of 1 minus zeta square divided by zeta, and the value of omega d is equal to omega n into square root of 1 minus zeta square. Okay, so similarly we have the definition of peak time, TP, that's called as time at which response reach its peak value. Okay, this also has one formula, that is TP, that is peak time is given as pi by omega d. Okay, so we are going to derive these formulas as well in the next session. So the next definition is for peak overshoot, or that is called as MP, the largest error between the reference input and output during the transient period. Okay, so that's called as peak overshoot, and in generally we can say that peak overshoot MP is equal to the response which you are getting minus 1. Okay, yeah, 1 is for unit step. Okay, whenever we have any unit step signal, we know that the value of amplitude is 1. So in generally we can say that the value of MP, it is equal to e to the power minus pi zeta divided by square root of 1 minus zeta square. If you want to take its percentage, we need to be multiplying into 100. Okay, so this also we are going to derive this expression here, okay, in the next session. So the next last final thing is settling time. Okay, so now what is the settling time? Time required for response to decrease and stay within the tolerance band. Okay, that is, within the tolerance band means we can take any tolerance band value, that is the tolerance value, it depends upon you how much you use the response. So that's why in generally it should be within plus or minus 2% of error. So if it is plus or minus 2%, the value of settling time is, which you are getting, is 4 divided by zeta omega n. Okay, this again we are going to derive it. So yeah, that's all. These and all are the few definitions here. If you want, you can take it down. Okay, these are the 5 definitions and all the time response specifications. Okay, that is delay time TD, rise time TR, peak time TP, peak overshoot MP, and settling time TS. These and all are the time response specifications which you need to be knowing. So that's all for this session. Please like, share, subscribe. Okay, and also if you want to refer the model question paper solutions, you can go to our channel and refer our playlist. So it would be appearing on the right of your screen now. So please refer our videos. All the model paper solutions have been solved for this subject and all the other subjects related to electromagnetic theory, principles of communication system, microcontrollers. Okay, so please refer the videos and try to score good marks. So that's all. Like, share, subscribe. Thank you.